but since these are things that you should have seen already, then I'm gonna do it in a matter of examples. Okay, so I'm gonna do some examples just to refresh your memory. So let's see, linear inequalities. By the way, what's the difference between, let's see, who can tell me what's a difference between an equation and an inequality? Yes.
In an equation, the left-hand side and the right-hand side are separated by an equal sign, whereas in inequalities they're separated by a greater than or equal sign, or less than or equal sign, or just a greater sign.
Okay, so let's do a little elementary second grade exercise. I'm gonna write a symbol and you tell me which one is it. Is it less than or is it greater than? What is it? Okay? Okay, let's go. Okay, good. This one? Okay. Okay, good. That's safe. No, you could be surprised how many students I see, writing the wrong symbol, and then of course, if you interpret the symbol wrong, then that's it. Everything goes downhill from there. Okay, good. And you understand what this means, right? When you say you're down equal to, you understand what that means. Okay. So, okay, let's do another little exercise. Tell me true or false.
False.
Okay, so that's false. How about this one?
True.
How about this one? Wait.
False.
Okay, good. And then
False.
okay, good. Safe. All right. So linear inequality. So what's a linear inequality? It's just like a linear equation. It's just that instead of having the equal sign, you're gonna have one of the same, right? Now, what's one of the fundamental differences between a linear equation and a linear inequality? Yes.
Linear equations have usually only one answer, while linear inequalities have a range of answers.
Very good. In fact, infinitely many, most of the time, right? So the point is that here, when you solve equations, typically if it's a linear equation, you either have one answer or the entire real line or no solution. Those are the three cases, right? We saw at the beginning. But in general, when you solve equations, you will have 1, 2, 3, a finite number of answers, a discrete set, or the entire real line. While when you solve linear inequalities, you either have no solution whatsoever, or you always have a range, an interval on which the solution works, but then there are infinitely many numbers there, because between any two numbers, there are infinitely many real numbers. Yes? So we need to discuss how we give the answer. We no longer give the answer as x less than something. Typically, because there are infinitely many numbers like this, we provide the answer in two ways. We draw a picture of it, that's the graphical representation, or we use what we call interval notation. Okay? So I just want to make sure that you remember this, so let me remind you of this stuff. Okay? So these examples, I want you to let's graph the inequality and write it in interval notation. Okay? So graph the solution set and write it in interval notation. And from now on, every time that I ask you to solve an inequality, I always want to see the answer in interval notation. Okay? So in interval notation. And let's see. Let's start with stuff that we don't need to move things around, just to get the basics fixed. Okay, so let's do something like this. By the way, number 3 is what we call a compound inequality. Okay? There are two inequalities in one here. It's an AND type inequality. Talk about that first. All right, so this one. here there's nothing to do. We already have x greater than 5. So what's the solution for this? Let's see, who can tell me one solution for this? 6. How about another one? 7. Any number is bigger than 5. So, there are infinitely many. So you cannot write them all down. So what we do is we draw a picture. And if you don't want to draw a picture, then there is an alternative way that represents that picture, which is what we call interval notation. So how do we sketch this? Well, you draw your real line. Just put the number that you care about, which in this case is 5. Now we need to have a way to say whether we want 5 to be part of the solution or not. So I ask you, is 5 part of the solution to this inequality?
No. The field circle and the circle, right?
Good. So in this case, when 5, the point is not part of the solution, what we do is an open circle. Okay? If you want it to be part of the solution, we do a closed circle. So in this case, we do an open circle. This here we're letting, we're saying I don't care about 5. And then what do we want? Do we want to go right or do we want to go left?
Right.
We want to go right because that's where the big numbers are. So you do something like this, and then you chain that part. Do you understand this? So this is the graphical representation, and then the interval notation is basically, another way of describing this set of numbers that are bigger than 5. And what we do is, let's look at the picture. The shaded region, it begins at this number, right? Not including this number. We will say how we write that, and then it goes all the way to the right non-stop. What do we have all the way to the right? Positive infinity, right? So we literally write that. So the interval notation. So we do 5, starts at 5 and then goes all the way to positive infinity. Now around infinity, we always will do parentheses. And then we need to say something about 5. So when you have an open circle, meaning that you don't want 5 to be part of the solution, what do we write here? We write parentheses. So parentheses means I don't want this point to be part of the solution. So open circle means parentheses. If you had a closed circle, meaning if 5 is part of the solution, then we write square bracket. Okay? Square bracket means include, parentheses means don't include. And whenever you write infinity or negative infinity, if you're going left, that will be negative infinity, we always write parentheses, because infinity is not a number. Okay? So it doesn't make sense to include infinity. What are you including? What is it? So around infinity, we always write parentheses. Are we okay with this? So basically, the interval notation tells you where to begin and where does the interval begin and where it finishes. That's what you write. And then you decide whether to use brackets or not, depending whether you're including or not. So let's see. For number 2, the picture will be very similar. It's just that in this case, we do a closed circle around 5, and then we go right. And the interval notation here will be bracket 5, infinity. Do you understand this? So when you see this, this means all numbers that are greater than or equal to 5. All real numbers greater than or equal to 5. Okay. And then for number 3, now as I mentioned, this is an untied inequality. There are 2 inequalities here. Okay? There are 2 statements here. We're saying that x is greater than -2 and less than or equal than 5, at the same time. Okay? In other words, it's between -2 and 5, including 5, not including -2. That's what we're saying here. Okay? X is between those 2. And so the picture should be pretty straightforward, right? So here is -2, here is 5. Should I include -2? No. So we draw an open circle. Should I include 5? Yes. So we draw a closed circle and then anything in between. Do you understand this? And so what would be the interval notation?
Parentheses, -2, 5 bracket.
5 and then square bracket. Okay. Questions? All right, perfect. So then let's go ahead and let's now solve some inequalities. Actually, let me keep it the same. So let's graph and then write down some interval notation. So let's do 4x minus a greater than or equal than 12. Yeah. And let's do 6 minus 3x greater than 12. So remember, the way you solve linear inequalities is exactly the same way as you solve linear equations. You move stuff around the same way, with the same rules to isolate the variable. There's only one little detail that you need to be aware of, which is if you multiply or divide by a negative number, you need to flip the direction of the inequality. Okay? If you multiply or divide by a negative, if you add a greater than, it becomes then a less than, or the other way around. Okay? If it was less than, it becomes greater than. Other than that, it's exactly the same as if you were solving a linear equation. You can add both sides, subtract both sides, and all of that. All right, so let's see. Number 4. We move the negative 8 to the other side. So we get 4x greater than or equal than 20. And now we divide by 4. So always, always ask yourself, am I dividing by a negative? So in this case, 4 is positive, so that means nothing happens to the inequality, it stays like that, okay? No need to flip it. So we get that x is greater than or equal than 5. Okay? All right? So now we graph this. So here is 5. Should I include this?
Yeah.
Include it. And where do I go? Right or left?
Right.
So we go right. That's a picture. And it's good practice to draw the picture even if they don't ask you for it. Because anyway, when you draw the picture tells you exactly what interval notation you need to write. Okay? If you draw the picture, then it's pretty straightforward to write the interval notation. So what's the interval notation? So bracket 5, comma infinity. Good. Questions? All right. So that's number 4. Then how about number 5? So if you want, you can always avoid, for example, here, if you leave x over here, eventually we have to divide by a negative 3, and then we need to flip, okay? You can always avoid that if you want, but just then, if you have a negative coefficient for the x, just move that to the other side, because when you move it to the other side, it's going to be positive. But then you need to understand that even though you're seeing the greater than symbol, when x is over here, in other words, what does this mean? If I say this, what does that mean?
3 is greater than
Or x is less than 3.
Good. So this means 3 is bigger than x, but what's another way of saying this? X is less than 3. So if you're going to draw the picture, because some people say, oh, it's pointing that way, so you always go right. No, be careful, because that works only when your variable is over here. If your variable is over here, where should I go, right or left? In my picture. Where do I go?
Left.
We go left, because that's where the smaller numbers are, right? So you have to go left. So, if you move your variable to the other side, be careful, because it may not be what you're used to do, okay? So in other words, what I'm saying is you may be able to avoid, you can always avoid dividing by a negative, but then you need to be willing to move your variable to the other side, if needed. I'm going to leave it there, that way I show you, we have an example of dividing by a negative, but it can be avoided, okay? All right, anyways, subtracting 6. Get negative 6. Now I'm going to divide by negative 3. Because I'm dividing by a negative, then this guy flips. Instead of greater than, is now less than. And then we have x is less than 2. Do you understand this? All right.
Wait,
Why is this negative?
I was about to say that.
I don't know. It's plus 6. It's plus minus 6. So I will be negative 2. Okay. All right, we're good. Yes? All right. So here's negative 2, open circle, go left. So that will be, who can tell me the interval notation?
Negative infinity, negative 2.
Negative infinity to negative 2. And then?
This is
Parentheses. Good. All right, question? questions about interval notation or dealing with linear equations, with linear inequalities? Okay, good. So now we know linear inequalities. As I mentioned, number 3 is what we call a compound inequality. So let's do a couple of those, and then we are ready to take a break, and then we do absolute value. Because what happens is that when you solve an absolute value inequality, you're going to get a compound inequality. There are two types of compounds inequality. There are AND types and there are OR types. Okay? And so you need to know how to deal with both of those. So compound inequalities. All right, so let's see. Solve, and we have here number 5. So this is number 6. Let's do something like this. And let's do this. All right, so let's draw a picture of these 4 inequalities. Okay, in 7, 8, and 9, there's nothing to do. We just draw a picture and that's it, right? And then write the interval notation. But for number 6, we have to do a little bit of work. Now, when you have something like number 6, as I mentioned, there are 2 inequalities here. Okay, so this is a shorthand way of writing an AND type inequality. In many instances, there is a little shortcut that you can actually solve, like something like this, when the variable is only on the inside, there are no variables outside. It's really easy to just work at once with both inequalities, and then you just, manipulate this expression as if you were, let's say, solving this one, 2x plus 4 less than or equal than 8. Just remember that there are 3 sides now, left, middle, and right. So whatever you do, you need to do it to all the sides. You subtract 4, you do it to the 3 sides, and so on. And that way, you can solve both of them simultaneously. The thing is, you have to be careful because if you have a negative here, when you divide, you have to flip 2 signs, and sometimes you may forget and all that kind of stuff. So, I personally, prefer to do this, but you do what you want, okay? But I like to split this into my 2 inequalities. This is a good mindset when you are solving absolute value anyways. So let's get used to it. So there are 2 inequalities here, and remember this is an AND type. So the first one is 3 is less than 2x plus 4. So just ignore this part. That's your first inequality. And the other one is this one over here. Okay? Now what's important is the word. You need to put here the word AND. Because remember, we're saying that this quantity, the stuff in the middle, has to be simultaneously greater than 3 and less than or equal than 8. Okay? It has to satisfy both. That's why we write the word AND. Do you understand this? Why I wrote the word AND? So now, solve it as usual. So here we're going to get -1, then divide by 2. And so here we're going to get 4 and divide by 2. Okay? So we have the statement -1/2 is less than x and x is less than or equal than 2. If you wanted to, you could recombine these. I'm not going to do it, but just going to show you, you could recombine it like this. And this is what you would obtain if you did it by itself, right? If you subtract the 4 on both sides and then divide it by 2, everybody, then this is what you would obtain. Okay? But let me keep it at the AND level. Now, the way that we solve, that we graph something like this is the word AND means intersection. So when you have 2 sets, the intersection is whatever they have in common. Okay? The word OR means union, just means combine the two pictures. Okay? So on the same picture, we're gonna graph both inequalities. So let's see, let's graph the first one. So we have -1/2. That's an open circle. Where should I go, right or left? For the first one. So we go right because x is bigger. And then for the other one, we have a 2 as a closed circle. Should I go right or left? We go left. And now, because we're doing an AND type, that means that we need to take the intersection of the two pictures. In other words, where they overlap, the common part. And hopefully you can see that what they have in common is between -1/2 and 2, right? So the common region is this one right here. So that's our solution. So we do the intersection. So here, AND means intersection. Oh, so I'm not ready. That's the intersection. And therefore, what's the interval notation for this? So the interval notation is parentheses -1/2. So solution set is -1/2, comma 2 square bracket. Okay? Again, this one in particular, you could have done it by just solving the three of them simultaneously. Okay? But it's nice to understand that there are two inequalities really in here. And when you have an absolute value, that's what happens. You get two inequalities. Okay, questions? All right, so let's write down. So what happens in number 7? Let's see, here there's really nothing much to do. So here we have 2, and here we have 4. Let's see, there's an open circle to the right. That's an open circle to the left. And because we have the word and, what are we supposed to do? We need to look at the intersection. So what's the common region here? What's the common region? So between 2 and 4, right? So the solution here would be 2,4. Parentheses around. All right. How about number 8? Let's see. Let's draw a picture for number 8. So here we have 2. Here we have 4. Here we have 4. So x bigger than 2, that's open circle to the right. X less than 4, that's open circle to the left. Okay, so what do we do now? So what does the word or stands for? So that's union. So it's either one or the other, right? So either x is bigger than 2 or x is less than 4. So that means union. In other words, combine. So when we combine, what do we get? So if you combine the blue one, it's all the way up to 4, not including 4, right? But then if you throw in the red one, piece of it is already shaded, that's okay. But then the other part is shaded. And notice that even though 4 is not okay with the blue, it is okay with the red. So it's included, okay? In other words, we have shaded the entire real line. Do you understand this? You combine the two, you get, no? What you don't understand? Okay, so do you understand what's here? Right, so this one says x bigger than 2, so that's the red one with the open circle. X less than 4, that's the blue one with the open circle. Now, the word or means union, means give me a number. It's either greater than 2 or less than 4. Whatever number you want would be one of these two guys. As long as one of these is true, the whole statement is true. That's what or means. For example, we can say, we are taking this class now, or we are at the beach. Is that a true or false statement? That's a true statement because we're not at the beach, but we're taking the class. But if I say we're taking the class and we are at the beach, is that true or false? That's false, because for an and statement to be true, both have to be true. Okay? Or you only need one of them to be true for the or to be okay. All right? So that's what's happening here. You give me any number, it's going to happen to one of these two categories. Whatever number you want. Okay? So now, in terms of the picture, you look at it, or means union, so that just means combine, okay? So take the blue part, the red part, and put them together. So the blue part does this. Everything less than 4. So up to here, okay? So all of this is taken care of by the blue part. So if you give me a number that's less than 4, that will be a true statement here because it's going to satisfy this guy. Now, what if you give me 5? Or 4 itself? You give me 4, that's not good here, but now it's good here. So that's why you also change the other part because look at the red. Now the red takes over. Let me change the color here. And the red takes over and change this part over here. And notice that 4 itself is also included, even though it's not good for the blue one, it's good for the red. So we're good. Okay. So now you look at the picture and you see that the entire real line was shaded. So what would be the solution? Negative infinity to positive infinity. So any real number, any number that you give me is either bigger than 2 or less than 4. It has to be one. Okay. So it's possible that when you're solving a compound inequality, you get this kind of stuff, that any number does the job. Okay? That any number works. Questions? Okay, now let's take a look at number 9. So what's going on here? What's the picture? So let's see, here is 2. Here is 4. Let's see, for the first one, where do I go? For x less than 2, should I go right or left?
Left.
I go left. And for the other one?
Right.
Go right. Yes? So now here, you have to be very careful. Okay, so you have to look at the original one. What does it say here? And. So what does and means? Intersection. So you need to look for common region. Is there anything common here? Do the regions overlap?
No.
They don't overlap. They go different ways, so they have nothing in common. So that means there is no solution. So the solution set is empty. Do you understand this? No solution whatsoever. Now, what if instead of and, it was or? So, that's the same one. Same thing. So, x less than 2 or x greater than 4. It's the same as the one above, but instead of and, we're doing or. So, it's not really the same. So, these inequalities. So, it's an or type now. Let's see, same picture. Going left. Going right. Now this time, because we're doing or means union. Just put them together, okay? So it's this part or this part, okay? So you just check both of them. So in other words, it would be this one or this one. In other words, the only thing that doesn't work is anything that's between 2 and 4. If you give me a number between 2 and 4, that's when I make this false because it's not going to satisfy the first one or the second. Okay? But if you give me any number that is in any of the shaded regions, it will either satisfy the first one or the second one, so it will satisfy the or statement as a whole. Do you understand this? Okay, so how do we write this using interval notation? Yes?
It's negative infinity 2 parenthesis.
Yes?
And then the U for union.
Yes?
And then parenthesis 4 and then positive infinity.
Good. So in other words, since we see that we have 2 pieces here, that's why in these cases the picture is really helpful. You literally write down the pieces, okay? The first piece, what is it? From negative infinity to 2, right? The other piece is from 4 to infinity, and then you combine them using the union symbol, which is just a big U, okay? In this case, the picture kind of spells out for you how to write it down. Okay, good. Questions? All right, so we are ready to do absolute value. So let's talk about absolute value inequalities, okay? All right, so let's see. I'm going to illustrate 2 examples, and then from those 2 examples, we're going to get a general idea on how to deal with absolute value inequalities, okay? We're gonna write down the strategy, and then we do a couple more examples, and then that should be good. All right, so solve, and let's write absolute value of x greater than or equal than 5. And then the other one I'd like to do is absolute value of x less than or equal than 5. Let's focus on the first one, okay? So let's try to solve this absolute value of x greater than or equal than 5. Let's see, who can give me some solutions? Yes.
5 and -5.
Okay, good. Give me two more solutions.
Infinity.
What is it?
Infinity.
Well, 0 doesn't work.
6 and -6.
This is literally like.
Infinity is not a number.
No.
Yes.
What was the number that the names already? Just I don't know. the
Tell me, I'm gonna tell you if they work.
name. -7.
-7, okay, good. Another one? -9, okay. 9, okay, good. So, as you can see, we're jumping back and forth between positive stuff and negative stuff. It doesn't matter because at the end we're taking absolute value, right? Now, you have to be careful where you jump. In other words, you need to avoid a certain region. What region do you need to avoid when you're jumping around the number line to give you solutions? Anything that's between what? Anything that's between -5 and 5 is a forbidden region for this inequality. Yes? You give me something in there, you put it here, it's not going to work. Right? Because it's different from 0, it's going to be less than 5. And that's not what we're looking for. So, if you think about a picture here, here is 0. Okay? Now, because we have a 5 there, then it kind of gives you a boundary. So, it's important to write down these two numbers. So, the real line now is split into 4 regions. Okay? There are 4 little intervals here that we have. And you know, where do you need to be if you want to be able to satisfy this inequality? Well, you want your distance from 5 to be greater than or equal to. So that means, you know, -5 and 5 are good because that's when you give you exactly distance of 5. But then if you want to be bigger than 5 in distance, that means you better be over here or over here. Do you understand this? Either less than -5 or bigger than 5. These guys, I don't know. Because if you are in any of these two regions, it's too little, right? The distance is less than 5, and that's not what we're looking for. Do you understand this? So in other words, for this inequality, the picture will look like this. And as long as you are in one of these two places, you're good to go, right? So you're either here or here. You cannot be in both at the same time, so it's only one of the two. In other words, what type of inequality is this? This is an OR type, because you are either over here or over here. Do you understand this? So, the absolute value of x greater than or equal than 5, that means that x is less than or equal than -5 or greater than or equal than 5. This corresponds to this piece, and this one corresponds to this piece. Yes?
Could you write that in?
Yeah, we're going to write it into my notation now. But, so, the thing is that when you have absolute value of something greater than or equal to a number, this is how you break it up, okay? You can get rid of the absolute value, you're going to get two inequalities. It's going to be an OR type, there's a greater than, and this is how you do it. You are either to the left of the negative version of the number or to the right of the number. Yes? So less than or equal to -5 or greater than or equal than 5. And then if we write it into my notation, the picture helps you. Okay? So first part would be from -infinity to -5 with square bracket, union, and then the second part starts at 5 and goes all the way to the right. So that would be 5 to positive infinity. Do you understand this? Okay, good. So, greater than or equal to, or greater than, notice that if we didn't have the equal to, it's the same thing. Because we had open circles here instead of closed. And it would be parentheses. That would be the only difference, but the rest of the ideas are the same. So, let's say greater than to put both of those together. When it's greater than, you're going to have an OR type, and this is the scenario that you're going to deal with. Now let's take a look at the less than situation. So this time we have absolute value of x less than or equal than 5. So again, you have the same setup. Here is 0, here is 5, here is -5. Turns out that we also want the endpoint, right? So now we have 4 regions, and we need to decide which ones are the ones that are good for us. Okay? So let's see. If you want absolute value to be less than 5, we already took care of the equal to 5, which are the closer. What regions do we need to be? Let's label them 1, 2, 3, 4. So what regions do we need for this?
2 and 3.
Region 2 and 3, right? So if you pick something here, that's gonna work because the distance from 0 is less than 5. And if you pick something over here, it will also work. Does everybody understand this? This is a no-go, and this is a no-go. Okay? So as long as you stay here, you're good to go. In other words, in here, this means that x has to be between -5 and 5. In other words, this is an AND type inequality. Is that clear? So remember, there are 2 statements here. This means -5 is less than or equal than x, and x is less than or equal than 5. Okay? And if we write in interval notation, that would be -5. So, moral of the story, if you have in an absolute value inequality, if you have a greater than, when you isolate the absolute value symbol and so on, if you have a greater than, that's an OR type. If you have a less than, that's an AND type. Okay? And then you solve it accordingly. All right. Questions? Okay, so let's write down the general statement, and then let's do a couple of examples. So, I guess method of solution is the following. So first, you isolate the absolute value. Then we're gonna have the following. So suppose that, now I'm gonna write the statement. So suppose that u is an expression, let u be equal to some expression. And let's say that a, which is greater than or equal than 0, is a real number. Okay. Then there are several things that we could get. Number 1, absolute value of u less than a. Number 2, absolute value of u less than or equal than a. But they go together, if you will. And greater than a, and then greater than or equal than a. Okay, so what does the first one mean? So how do we solve this? So when you have absolute value of something less than a number, what does this mean? It means that u is between -a and a. Yes, that's what it means. If it's less than or equal to, exactly the same thing, but then you put the less than or equal symbol. So remember that these are AND types. And if it's greater than a, then it's an OR type. It means that either u is less than -a, or is bigger than a. And over here, less than or equal than -a, or greater than or equal than a. And, you know. And let me just write down the picture. If you forget this for some reason, always draw the picture. The picture will tell you what it is. As long as you know what absolute value is, you can always recover this information. Remember, the picture for this one is, here is 0, here you have a, here you have -a, so you have to be in this region, okay? Either this one or this one, any of these two are good. And the other one is the same thing, it's just that you have closed circles, okay? Over here, because you want absolute value to be greater than A, then now you have to avoid the previous regions. This time you have to be here or here, because you want the distance from 0 to be more than this number. So you will be either to the right or to the left of the negative version, so that the distance becomes big. And the picture for the last one is, same thing. It's just a closed circles. Okay, so if you forget this part right here, then the pictures will allow. Just draw the picture, and the picture will remind you how to do it. Okay. All right. Questions? We're good with this. So let's do some examples. So examples. Solve. Let's see. Let's do absolute value of 2x minus 3 plus 5 greater than 20. And let's do 5 minus 4x and absolute value minus 4 less than or equal than negative 1. Oh, wait. Let me write one remark. So remark for a greater than 0, absolute value of a, let's say, greater than negative a, and then absolute value of a less than negative a. And then I want you to understand that whatever I say here also applies for if I put an equal sign, okay? But I'm just going to do the greater than and the less than. But also I could have here greater than or equal to, less than or equal to, any of those two. Let's see the first one. What can you tell me would be the result here? What should be the conclusion? U is an expression, okay?
It's gonna be less than.
What's the conclusion? That's always true. Very good. Remember, when you do absolute value of something, that's always 0 or bigger, right? Regardless of what's going on inside, the moment that we're taking absolute value, that will never be negative. It's always positive or 0. If we have a negative number over here, because by saying that a is positive, then the minus is negative. If we have a negative number over here, that means that regardless of what you put in here for you, it's going to be true, no matter what, right? Because something positive or 0 is always bigger than something negative. So, solution here is, this is always true. So, always true. So, the solution here is all real numbers all the time, okay? How about in this situation? You have absolute value of something less than or equal to something negative. What do you think happens here? It's always false, right? There's no way that something that's positive or 0 is less than a negative number. So that's always false. It's always false, so it has no solution. Do you understand this? So this covers all the cases. Remember, these properties that I wrote up here is assuming that you have something positive over here, and then that's when you break it up. But if you have something negative, then just look at it. If it's greater than or greater than or equal to, or real numbers. If it's a less than, then no solution. Okay? All right. So that's a remark. So now let's do problems. Let's see. We have these two, and then I want to do one more, but let me give you some time. So do these two. Take attendance. Like that? Antoine Antela.
Here.
Gabriela Rue. Isabela Bagallas. Okay. Anabel Balmori. Just, I don't remember saying your name, but I remember seeing you last time. So it's Okay. Kevin Bonson. Wyatt Boyington.
Here.
Brianna Brandt Moncada. Ariel Busutil. Samantha Cabrera. Juan Camacho. César Castañeda. Natalie Castañeira. Mary de la Cruz.
Here.
David Fajardo. Lexi Galvez.
Here.
Maximilian George Pierre. Zane Gettinger.
Here.
Raúl Izquierdo.
Here.
Farzana Khan. Gabriel Culi.
Here.
Bernardo López. Natalie Martínez. Dayani Plasencia. Arisai Rodríguez. José Rodríguez. Zan Rodríguez. Sara Sacrani. Lucas Sam. Lucía Sánchez.
Here.
María Sánchez.
Here.
John Paul Sánchez.
Here.
Shane Soto.
Here.
Deandre Toledo. Gabriel Trumpeter. Genesis Trujillo. Héctor Vega. Christopher Vonderhaar. Alexander Wagner. Is there anybody that I didn't call out? Okay, so what type is number one? Is it or and type? What is it? Or type. Okay, good. So what's the first step? We need to isolate that absolute value. So step 5. Okay. So what are the inequalities that we get from here?
2x minus 3 is greater than 15, or 2x minus 3 is greater than negative 15.
Less than. So I always prefer to, just thinking about the picture, to the left of negative 15 or to the right of 15. Okay. So less than negative 15 or greater than 15. Do you understand this? So again, remember, if you don't remember this, for some reason, well, if you don't remember this, just draw the picture, okay? Let's say that you don't remember the property that we did above, just draw the picture. Because there is a 15 there, that means that you're gonna have it here, and then you also need to consider negative 15. You do need to remember this, right? And then just think about, where do you need to be? What region do you need to pick to satisfy this inequality? Okay? And at this point, hopefully you realize that you have to be here or here. This is not good and this is not good. Yes? So less than negative 15 or greater than 15. Okay? And now we solve this as usual, as we were talking before. So this would be, what is this? Negative 12. So we have x is less than negative 6, or, so that would be 18. So x is less than negative 6, or x is greater than 9. And now let's draw a picture. Again, here, even though I'm not asking, if I don't ask you for the graphical representation, you should do it, because the picture is the one that will tell you how to write the interval notation. Okay? So it's good practice to draw the picture all the time. So it's negative 6, here is 9. Should I include negative 6? No. Should I include 9? No. For negative 6, where do we go, right or left?
Left.
We go left. or 9?
Right.
You're right. And because it's an OR inequality, we just combine the two. So what's the solution?
Negative infinity to negative 6, not including. Or 9 to plus infinity, not including.
So in some places you write the word OR, but typically we like to write the word union. Yes. 9 to infinity. Now when you're doing the homework, be mindful of that because I think that would require you to write the symbol union, but there could be problems in which they tell you to use the word OR. Okay? It's the same thing, right? This or this. Okay? But I think in the homework most of the time you will be using the symbol union anyways. The union symbol. Okay. Questions? Yes.
Why did you say switch again the sign for the negative 15 one? The negative 15 side, like why did you switch the sign again?
So remember, you want this stuff to be, the distance from 0 of this to be bigger than 15, right? Let's go to this picture. So 15 is an important number, so here we have 15, and also negative 15, because this point is a distance of 15 from 0. So you should not be ignoring the negative guys. Now, there are 4 places here. What regions do you think this quantity has to be to obey this inequality? Remember, the statement here is the distance of this stuff is more than 15. The distance from 0 is more than 15. That's the statement. So clearly, if you're here, it's fine, right? Like you're 16, 17, that's okay. So that takes care of the bigger than 15. Now, this is a no-go because it's less than 15. This is a no-go because the distance from 0 is less than 15. Yes? Now, how about you are over here, like negative 16 or negative 17? The distance is still more than 15. So you should be considering this part as well. Then when you look at it, it's less than negative 15 or bigger than 15. And in general, that's what we said here. If you have absolute value of something greater than a number, a positive number, like 15 in this case, means this. Either the stuff inside the absolute value is less than negative, whatever the number is, or is bigger than the number. Right? But if you don't memorize this, then just draw a picture. The picture will tell you. Like analyze it, think about it. Okay, remember, absolute value is distance from 0. Keeping that in mind, that will allow you to recover that. Okay? All right, good. How about number 2? What do we need to do? We add 4. So we get absolute value of 5 minus 4x is less than or equal than 3. Now, what type of inequality is this? Is it or and? It's going to be an and type. So to break up the absolute value, what do we need to do here? If you want the distance to be less than 3, in what region do you need to be?
2.
Between what and what?
2 and 3.
Between negative 3 and 3, right? So this means that 5 minus 4x is between 3 and negative 3. Yes? Again, if you don't, once again, literally just following what we have in here. Okay? Now, if you don't remember this, draw the picture, and the picture will tell you. Okay? Okay. Draw a picture, the picture will tell you. All right, so you see here, if I try to solve this at once, you could try to do it. It's just that then this is negative, and you have to flip the 2 signs. I don't like that, so I would rather just break it up. So I'm gonna break it up. So from here, I'm gonna get 2 inequalities. The first one is negative 3 less than or equal than 5 minus 4x. And that word is very important. 5 minus 4x less than or equal than 3. Okay, so let's solve. I'm gonna move the 4x to the left and the negative 3 to the right. So I'm gonna have 4x less than or equal than 8. So x less than or equal than 2. Now here, I don't want to multiply, I don't want to divide by a negative, so I'm going to move the 4x to the right and the 3 to the left. So I'm going to have 2 less than or equal than 4x. So x greater than or equal than 1/2. And you do this however you want, okay? This is just a matter of preference at this point. Point at the end, you have to have the same answer, of course. All right, so let's see. So here is a 2. Here is a 1/2. And here is 2. Let's see, 1/2, closed circle. Should we go right or left?
Right.
So we go right because 1/2 is less than or equal to x. So x is bigger or equal to. So we go right. And then for the other one, we include 2. Do we go right or left? Go left. Because it's and, remember, we have to look at the intersection. That's the common region. And so in this case, we get solution is bracket 1/2, comma 2. Bracket both times. Okay. Questions? Yes.
Can you explain when we use and or again?
Okay. So okay, let's go here. The picture. Look at this picture. So this means that you have to be in the shaded region to satisfy the inequality. Okay. Now, can you be in both places at the same time? So we use or because you are either here or here. So if you're gonna talk about this in regular language, you have to use the word or because you are either on this side or on this side. Now let's look at the above picture. You have to be on the shaded region, right? So notice that anything that's on the shaded region is both less than a and greater than -a. It satisfies both conditions at the same time. That's why we say it's and. So between -a and a means greater than -a and less than a. Because this means between. It's between these two. So it's bigger than this and less than this. So that's how you know. So I guess the general thing is when you're breaking up the absolute value, if it's a less than, then that is an and type. If it's a greater than, then it's an or type. Okay? That's how you can remember this. Good. Are we okay with this? All right. So there's this one. And let's see, do one more about this. Okay, what do we get here? The solution. Does anybody agree with this? Okay, very good. So let's see. When you solve, remember the first step is that you need to leave the absolute value alone. So that's the first thing that we need to do. So when you leave the absolute value alone, you first subtract 9, so you're going to get a 1 over here. But then you need to divide by -2. Now, it's important to remember the rule. What happens when you divide by a negative? I have to flip this guy. So it flips. So it becomes less than. So now we have the following statement. Absolute value of 3x minus 5 is less than -1/2. Okay? At this point, there's no rule to look at from the one that we're saying above. You just think about this statement. You know the stuff in the left is always positive. or 0 at best, right? So I should say at worst. At worst, this is 0, and if not, it's going to be positive. There's no way this can be less than negative half. Does that make sense? So there's no solution. No matter what x you throw in here, you're not going to get something that's less than negative half. So no solution. So this is always false. So, no solution. Do you understand this?
So for the test, if we get like a no solution, we just write no solution.
No solution or the empty set, right? So if I ask you give the answer in interval notation, no, that's a set. So you just write this, or you know, just let me know that you understand that there's no solution. Or sometimes if you're doing the homework, I think what the homework asks you to write is DNE, right? Does not exist. You know, all of these things are equivalent stuff. Okay. Questions? Are you okay with this? I mean, I think that's if this would have been a positive 2. Wait. If this would have been positive 2, yes. If this would have. Okay, let me just do one more. So let's make it a positive 2. But actually, same problem. And now let's do this. So all I did was I flipped the sign. Instead of greater, I put less than. Okay? The rest is the same as before, just instead of greater than, I put a less than. What will happen here? Now this time it becomes all real numbers. Yes? Because the work is the same as what we did before. So we have something like this. It's a 1. Now you divide by negative 2. So as you know, we need to flip. So it becomes greater than negative 1/2. Yes? And let me kind of stress here. And we flip it. So now at this point, you know, we have the other side of the coin. Right? We have a quantity here that at worst is 0, at best is always positive, but no matter what, this is always greater than a negative number. Do you understand this? So you can put whatever x you want in there, it always works. So the point is that this is always true. So the solution here is all real numbers. And the way that we write this in interval notation is negative infinity to positive infinity.